In this example, we're going to find the surface area for a portion of this plane, z equals negative x, which lies inside the cylinder formed by x squared plus y squared equals 4. All right, so in order to do this, the first thing we want to do is find r of uv. In this case, it's going to be r of r theta. So what should we let x equal? Well, we'll let x equal r cosine theta. We'll let y equal r sine theta using polar coordinates. And since z is equal to negative x, z is going to equal negative r cosine theta. Let's also determine our AB bounds on u, or r, and then our CD bounds on my v variable, or theta. So theta, because we're inside a circular cylinder, theta is going to go from 0 to 2 pi. And then what is my radius going to be? Well, the cylinder will have a radius of 2, so that means that my r values are going to be between 0 and 2. So when I set up my integral, I've got a, b, and c, d. And my r vector in component form, I'll say r cosine theta, r sine theta, and negative r cosine theta. So we'll find our partials next. R partial r, that is going to be cosine theta, sine theta, and negative cosine theta. And r sub theta is going to be negative r sine theta, r cosine theta, and positive r sine theta. Our next step then is to find this cross product. So r sub r cross with r sub theta. The determinant matrix looks like what we have here. So calculating that cross product, we get r sine squared plus r cosine squared theta I, which simplifies to just ri. For the j term, my two products are both r cosine theta, sine theta, and when we are subtracting them, they cancel, so we have 0j, and then we've got r cosine squared plus r sine squared theta k, which is just rk. So the magnitude of this, the magnitude of r sub r cross r sub theta, is the sum of the squares. So that's r squared plus r squared, or the square root of 2r squared, or rather root 2r. So now that we've found this, root 2r, and we know our bounds, 0 to 2 and 0 to 2 pi, we can set up our area, or our surface area, I should say, integral. So my surface area is going to be the integral from 0 to 2 pi for theta, 0 to 2 for r, we have the square root of 2r, dr, d theta. And of course, this is very easy for us to integrate. I'm going to pause and write that out. And the brief amount of work I have for the area of the surface area for the portion of the plane inside the cylinder is 4 pi root 2. As always, email me if you have any questions. I'm here to help. Good luck out there.